Hello class, in this video we're going to talk about how to do a multivariate linear model regression in Excel. As you see here, we have our dependent variable as the house price in the last column, and these are the independent variable we're going to use to explain why we observe different house price. So these variables include Charles, whether the house is along the Charles River, the number of rooms the house it has, the age of this house, the distance to a major subway, etc. Okay, so to do the linear regression, let's go to data analysis. If you don't have the data analysis on your computer, you should go to File, Option, Add-ins, because this is an Excel add-in. Go to Excel add-in, go. You can choose the analysis tool pack here and press OK. Then you'll be able to find the data analysis here. Suppose you have this, click this and then choose regression here. So first you're going to input y range. Include this is the y range, our dependent variable, and then our independent variable is this. Press OK, and since we crop the label in our data, so we will check label, and we can choose the output range here. Oh, it seems I have to click here to choose a output range, and then I would press OK. You will see the result. It seems Excel always give me this duplicate low and up 95% interval, so I'm just going to delete this. And to make this table easier to read, let's reduce the number of decimals to 3. And we're going to first look at this variable that in the INDUS. If you look at this description of this problem, you will see this variable means the number of retail business in this region. It's really it seems to be positive, which means this variable seems to have a positive influence on the house price. But if you look at the p-value, which is bigger than 0.05, which means this variable is not significant. Alternatively, you can look at the confidence interval. It has 0 in this interval, which means this is possible that this variable have 0 influence in our dependent variable, which is the house price. So in this case, this variable is not significant. On the other hand, if we look at rooms, okay, and this variable has p-value very small. As you see here is e to the power of -17, so it's very small, which means it's very significant, and so room is significant. And the magnitude of this impact is 3.658, which basically says one additional room would increase the house price by this amount, and the unit is $1,000. Similarly, if you look at Charles, which is a binary variable, it is also very significant and is positive, meaning if the house is along the Charles River, which means Charles is 1, then the house price would increase by $2,800. So that's what it means for this coefficient. So let's look at another one, a negative one. So if you look at a distance, which means the distance to a major subway station, the p-value is less than 0.05, which means this is significant. Okay, this is significant. So the distance has a significant negative impact on housing price, which means if the distance increase, if the distance to a major subway increase by 1 unit, then the house price will decrease by this amount, $1.491 thousand dollars. So that's how you interpret this coefficient. That's all for this video. Thank you.